So important purpose of using standard units, why we have to use the units, we have to study about them. So before going to start, if you are new to my channel, please subscribe my channel, press the bell icon for notification so that you will get the upcoming videos information. So let us start. As we know, physics is an experimental science. To understand physics or any experimental science, we must be able to connect our theoretical description of nature with our experimental observation of nature. Okay, so if we want to understand any physical or experimental concept, we need to connect the theoretical description to the experimental observations. So how we can do it? With the help of what? Units and measurements. So first we need to understand what is measurement. Measurement in day-to-day life, we used to say we used to measure different things like length or weight or height. So what is measurement? It is a comparison of unknown physical quantity with known physical quantity. Okay, if you want to measure something, we have to follow some rules. So it is given by this formula: Q, capital Q equal to N into U. Q is what? Magnitude of physical quantity. So N is what? Number. U is what? Unit. So let us say we are measuring weight of a given material. So weight, if we say, we will use to say in terms of kg. Q is equal to 6 kg. So here 6 is what? Number. Kg is what? Unit. So this measurement will depend upon two things: the unit in which physical quantity is measured and the second, numerical value. So what is the need of measurement? Why we have to measure the things? So in physics, we deal with large number of physical quantities like length, mass, speed, acceleration, time. So these quantities give clear understanding if we measure them. Okay, so like velocity, if we want to calculate the velocity or speed of a given object, then measurement is required. So velocity is given by displacement by time, like that power, force and work. So to measure these physical quantities, measurement is needed. So then what is unit? The quantity used as standard of measurement is called unit. Whatever we are using, we are measuring the things, we need to assign the unit, then only it will have some weightage. Let us consider length. If we just say number 10, it doesn't have any meaning. If we say 10 meter, then it will give the standard of measurement. That is 10 meter is related to what? We are measuring length. So here unit of length is what? Meter. Okay, so if we are saying 10 kg, that is related to weight. So unit of weight is going to be kg. So here unit of length is what? Meter. So like that, units are very useful. So physical quantities which can be described, used to describe the physics laws. So here we can have two classifications here: fundamental quantities or base quantities and derived quantities. So if we classify in terms of physical quantities, again if we classify the types of units, we can classify as fundamental units or derived units. So what are fundamental units? The units defined for the fundamental quantities are called fundamental units. Derived units, the units of all other physical quantities which are derived from the fundamental units. So these are fundamental units like length, mass, time. Okay, using these fundamental quantities, we should write the derived units like force, acceleration, velocity. So system of units, there are different system of units. have been used over the past years. So the first one is FPS, that is foot. F stands for foot, P for pound, and S for second to measure the time. So CGS system, centimeter, gram, second. So MK system, mass, kg, meter, kg, and second. So the one of the throughout the world we are using another system called SI system. So nowadays widely the people scientific field, they are using this system of unit. So SI system consists of base units and supplementary units. So you can see here the fundamental or base units, there are total 7 base units, and there are 2 supplementary units. So first one, length, mass, time, electric current, temperature, luminous intensity, amount of substance. So length, its unit meter, mass kg, time second, electric current ampere, temperature Kelvin, luminous intensity candela, amount of substance mole. So the symbol also has been given here. So another 2 supplementary units are plane angle, solid angle. So the unit is radian and steradian. So we other than these units, we have the practical units for large distances, small distances. So large distances, if we take we used to measure the distances from earth, that is called astronomical unit. Different planets, how they are far away from earth. So astronomical unit is helpful. Light year, the different distances between the celestial bodies. So parsec, these all are related to space, measurement in space, like planets, stars, whatever the objects that we are seeing in space or sky. Then practical units for small distances, like micron, angstrom, nanometer, Fermi. So 10 to the power of minus 6, angstrom 10 to the power minus 10, nanometer 10 to the power minus 9, and Fermi 10 to the power minus 15. So these are the small distances. So multiple and submultiple units. So if we write in terms of 10 to the power, in terms of plus or minus, then we will have the exponent form here, and this is the multiplier in this column, and prefix, what we are going to give the prefixes for the exponent form. If it is 10 to the power 12, that is called tera, and the symbol is capital T. From you can see tera to atto, that is atto is 10 to the power minus 18, symbol has been given. So like that, how you can give the prefixes to the exponent 10 to the power plus or minus. Just go through them, very helpful for you. So there are some methods to measure large distances. Indirect methods are there: echo method, sonar method, laser method, radar, and measurement of distances of heavenly bodies like parallax method, radio method. Okay, and small distances, if we measure, Avogadro's hypothesis is there, alpha Rutherford scattering, and size of molecule of a liquid. These all are for small distance measurements. So another important topic is dimensional analysis. If once we know units and measurements, so we can write the dimensional equation, dimensional formula for that. So what is dimension, how we can define it? The dimensions of physical quantity may be defined as the power to which the fundamental quantities like mass, length and time must be raised to represent the physical quantity. Okay, so to for example, if we take velocity, formula is what? Displacement by time. So first we need to write the formula, then we need to write the whatever the parameters involved in formula in terms of mass, length and meter length, mass, length and time. So if we take displacement, that is displacement is what, distance, length by time. Then if we write the dimensional formula for velocity, finally mass is 0, s by t it is m0 t0 l having to the power 1. So denominator we have time, so l0 m0 t to the power 1. So the dimensional formula for velocity will be l to the power 1 m to the power 0 t to the power minus 1. So like that we have to write. So what is dimensional formula? Expressing the physical quantity in terms of its dimensions is called dimensional formula. Okay, whatever the physical quantities are there, we are going to express them in dimensions. So as I written velocity, if we take force is what, mass into acceleration. Then m, acceleration is what, velocity by time. So dimensional formula will be m to the power 1 l to the power 1 t to the power minus 2. So how is dimensional formula written? So first what we have to do, first step, formula of the physical quantity we must write, and the quantity must be on the left hand side of the equation. So if we are measuring force, that must be on the left hand side. Okay, all the quantities on right hand side of the formula must be written in terms of fundamental quantities like mass, length and time. Okay, then third step, replace mass, length, time with m, l, t. Fourth step, write the powers of the terms. So these are the 4 steps you have to follow to write a dimensional formula. Then what is principle of homogeneity? According to principle of homogeneity of dimensions, all the terms in a given physical equation must be the same. If we take this equation of motion, s equal to ut plus half at square, if we calculate separately the dimension for all these 3 terms, s, ut plus half at square, they must have the same physical equation. Like s is what, distance, length, and u into t is what, l, velocity into time, l t to the power minus 1 dot t, and half at square, acceleration into time square. So finally what we will have, l is equal to l plus l. So all these 3 terms having the physical same dimensions. So this is called principle of homogeneity. So some of the dimensional formulas for physical quantities I have mentioned here. Just note on them, they are very useful for you. Area, volume, velocity, acceleration, force, work, power, pressure, density, strain, modulus of elasticity. So like that other important fundamental physical quantities, just you can go through them. So there are 4 category of physical quantities. Okay, first one is dimensional variable, dimensional constants, dimensional less variable, dimensional less constants. So dimensional variable is what, examples are force and work. They are having the dimensional formula. Okay, dimensional variables. Dimensional constants, some of the physical laws we will come across constants like gravitational Planck constant, speed of light, that is 3 into 10 to the power 8 meter per second. So some constant also have dimensional formula. And dimensional less variable means some of the physical quantities which doesn't have dimensional formula like strain, angle. So dimensional less constants. Some of the constants also doesn't have a dimensional formula, just we can represent them in terms of numbers 1, 2, 3, epsilon or pi. Okay, these are dimensionless constants. So what is the use of dimensional formula? So first, to check the correctness of equation. Second, to recapitulate a forgotten formula. If you forgot any formula, you can recapitulate by using dimensional formula. Third, to find dimensions of constants in a given relation. Fourth, convert the unit of physical quantity from one system to another. And the last one, deduce the relation connecting the physical quantities. So if you want to derive any relation connecting to the physical quantities, dimensional formulas will be helpful. So these are all the uses of dimensional formula. So I hope this video is informative, and especially for the students, those who have suggested me. So I hope you will get information from this video on units and measurement. If this video is helpful or useful for you, please like, share and subscribe my channel. Thank you for watching.